Welcome to the Genius Factory. Enjoy the video.
You start by preparing a reproducible environment so dependencies don't conflict. Create and activate a virtualenv, then install PyTorch or TensorFlow plus OpenCV and a detector library. This gives you model backbones and utilities. Next, gather and inspect labeled images, use Cocoa or Pascal VOC formats, or convert CSV to JSON, because models learn from consistent annotations. Once done, split data into train/val and test folders, and verify a few samples visually to catch labeling issues early. You now design the model pipeline. Pick an architecture that balances speed and accuracy for your use case. YOLO for real-time, faster RCNN for precision. Implement a data loader that yields images and normalized boxes, add augmentations like flip and color jitter to improve generalization, and set batch size based on GPU memory. Configure optimizer, learning rate schedule, and checkpointing so you can resume training. Train with validation monitoring. Use mixed precision to speed up training while preserving performance. You finish by evaluating model metrics like MAP and class-wise precision/recall to understand failure modes. Visualizing predictions helps explain systematic errors. For deployment, export the trained model to ONGs, TorchScript, or TF-Lite, and optimize with pruning or quantization for latency. If performance stalls, troubleshoot. Confirm label quality, address class imbalance with augmentation or reweighting. Reduce learning rate or regularize to fix overfitting, and validate preprocessing pipelines. Mismatched normalization often breaks inference.
Thanks for watching. If you found this helpful, don't forget to like and subscribe.